Some cameras utilize a bellows mechanism to adjust focus. The most obvious example being a view camera, like my 4x5 here, or my 6x17 back there. But also my RZ67 here utilizes a bellows. It's an internal bellows which is adjusted using the focusing knobs on the side of the camera. But whatever the case, the way the bellows mechanism works is if I focus on things that are closer to me, I have to extend the bellows, and if I'm focused on things that are further away from me, I compress the bellows. Now if you're focused on something close to where you're having to extend the bellows, care must be taken in your metering process because you may have to add exposure to your metered settings. So that's what we're going to look at in this video. So, at infinity focus on non-telephoto lenses, the bellows extension will equal your focal length. So, for instance, if I'm using a 150mm lens on my 4x5 here, and I focus on infinity, so just the furthest distance that the lens can focus on, the distance between the film standard and the lens standard, in other words, the bellows extension, will match the focal length. It'll be 150mm. If I'm using a 300mm lens focused on infinity, the bellows extension will be 300mm. Now that's on non-telephoto lenses. Telephoto lenses work a little differently. On telephoto lenses, if you're focused at infinity, the bellows extension will actually be shorter than the focal length. So for instance, I have a telephoto lens right here. It's a Fuji 400mm telephoto. And the way this lens works is if I focus on infinity, the bellows extension is only about 250mm, so quite a bit shy of the 400mm focal length. Now, by the way, that's what makes it a telephoto lens. Telephoto, by definition, means that when the lens is focused on infinity, the physical length is shorter than the focal length. So a 400mm lens only has a physical length of 250mm. That's what a telephoto lens is, but the term telephoto has been misused by people for years. People often just refer to their long focal length lenses as telephoto lenses. So for instance, if you had a 300mm lens for your 4x5, you might call it your telephoto lens because it's a long focal length. But guess what? It's not a telephoto lens. It's just a long focal length lens. It's only a telephoto lens if, when focused at infinity, the physical length of the lens, the physical length of the bellows, is less than the focal length. You'll see on this Fuji, by the way, it actually has a T on it. That's how I know for sure it's an actual telephoto lens. There's a special type of lens group called a telephoto lens group that must be put into telephoto lenses in order for them to be able to shrink the bellows extension. So this is a true telephoto lens, but the vast majority of lenses are not true telephoto lenses. And so it's unlikely you'll have to worry about this very much. Most people don't have telephoto lenses for their large format cameras. But if you do, just know that the bellows extension is going to be less than the focal length, even when focused at infinity. Now, if you're focusing closer than infinity, your bellows will need to be extended. So if you're doing a still life, you're doing a flower, you're doing a portrait, something where you're focused just a few feet in front of you or something much closer than infinity, your bellows is going to have to be extended quite a bit beyond the infinity position. In that case, exposure must be added to your metered settings. Now, if you think about it, it makes perfect sense why that would be. As you pull the lens away from the film, the light reaching the film is going to be weaker. It's no different than if I was shining a flashlight at you and I walked 10 feet back. It's going to get weaker the further I get away. So you have to add exposure to your metered settings to compensate for that weakening effect of the light. By the way, if you want to look up why exactly light gets weaker as you pull further back, look up the inverse square law. I'm not going to cover it in this video because it doesn't matter, but that'll explain why light gets weaker as you pull it further away. So if your bellows extension is beyond the infinity position, you have to add exposure. If your bellows extension happens to be twice your focal length, so for instance, a bellow extension of 300mm on a 150mm lens, if it's twice your focal length, then you add 2 stops of light. Now, by the way, that's assuming it's a non-telephoto lens. If it's a telephoto lens, I'm talking about not twice the focal length, but twice the bellows length at infinity. So like if I'm set to 500mm bellows extension on this lens, then I would have to add 2 stops of light because that's twice the bellows extension at infinity. I know it's kind of confusing with telephoto lenses because the bellows extension doesn't match the focal length. But on non-telephoto lenses, which is going to be the vast majority of lenses, if your bellows is extended twice the distance of your focal length, you have to add 2 stops of light. If your bellows extension is only about 1.5 times your focal length, then you add 1.3 stops of light, 1 1/3 stops of light. I know there's a lot of numbers floating around, it's hard to remember, so you know what the easiest thing to do is? Just get an app. So that app I showed you in a previous video, Reciprocity Timer, that actually has a built-in bellows calculator that will tell you how much exposure you need to add. So you go to the bellows, you put in your focal length, and then you put in your bellows extension. And it'll tell you how many stops of light you need to add. So that makes it a lot easier than trying to remember. Another app option here is one called Photo Buddy. That has a bellows calculator as well. You put in your focal length, you put in your bellows length, and then it'll tell you how many stops to add. And then you may have to carry a tape measure with you, because if your camera does not have a clearly delineated distance marker for the bellows extension, like mine doesn't show me really how long the bellows is beyond 160 millimeters. So I have to carry this tape measure with me. I know this seems kind of ridiculous, but you may have to be out there and then measure the distance between the lens standard and the film standard to see if your bellows extension is well beyond your infinity position. Just make sure it has millimeters on it, by the way. In the US, it can be a little hard to find tape measures like this that have metric on it, but it has to be millimeters because most lenses are measured in millimeters. The RZ67 has a great feature. On the side of the bellows, there's actually a little graphic that shows every possible lens you could use, and then it'll tell you how many stops to add depending on where you're focused. So for instance, if I'm using a 180 millimeter lens, and I'm focused at this distance, I need to add half a stop of light. If I focus on this distance, I need to add about 1 stop of light. So this has a nice handy dandy visual. But otherwise, carry a tape measure with you. This one I got at just like a fabric store. Nice small fabric, and it's not like a full Home Depot, tape measure. Carry one of those with you, carry the app with you, and then if you're focused on anything closer than infinity, see if you need to add light to your metered settings. So that's how you calculate bellows extension for your metering. I'll see you in the next video.